My name is Miranda Threewitt, and I worked on testing design and the mesh paddle wheel.
My name is Haley Martin, and I worked on the chassis design and compliant mechanisms.
My name is Zach Hunter, and I worked on traction control and prototyping.
My name is Craig Smith, and I worked on the chassis design and the compliant mechanisms.
My name is Margaret Lichtenfeld, and I worked on the testing and budget plans.
Our proposed project is called the Lunar Rover Convertible Mobility System. The system is made up of several main components: the convertible chassis, the compliant mechanisms built into the chassis, and the mesh paddle wheel with an additional integration of an adapted traction control system.
Our designed chassis will allow the wheels of the Rover to configure into multiple positions by translating the bars on the inside of the chassis. This will result in the user having the ability of both Ackerman-style steering and explicit point steering for precision and maneuverability, while also causing less dust interference than a Rover that implements skid steering.
Due to the invasive nature of lunar dust, having joints that contain moving parts such as hinges, pins, or bearings is problematic. Instead, we focus on motion through the deflection of carefully designed flexible members known as compliant mechanisms. These specific mechanisms allow for deflection of 45 degrees in either direction, and a total of 20 mechanisms work together to steer the Rover.
The wheels designed for this project are custom mesh paddle wheels that have a dual focus on mobility over loose terrain and packed crater surfaces. The wheel has an outer layer of spring steel wire mesh that allows sand and dirt to pass through, and an internal set of paddles attached to the hub. When traveling over packed surfaces, the outer wire mesh will remain above ground and be able to roll without interference of the paddles. When traveling in loose regolith, the mesh will sink into the ground and allow the internal paddles to contribute to travel, which will aid in traction while climbing steep hills.
Our traction control system will implement an adaptation to Ackerman steering to maintain traction over uneven terrain. It is not based on having prior knowledge of the terrain and will control each of the four wheels individually to minimize slipping.
Our team has designed a mobility system with the ability to transport a variety of science payloads into and out of craters. Our simple, cost-effective design ensures that abrasive dust will not degrade it, therefore it can be reused for multiple missions. Our lightweight rover allows for a greater mass allocation to the payloads, and our extensive testing plan covers everything from environmental situations to all loading scenarios.